Hello guys, welcome to my channel once again. For those of you that are joining for the first time, please do well to click on the red subscribe button for our channel so you can get more content. And for the existing ones, please like and share for more visibility. And if you have any question, please write it in the right comment section and I'll get to you. So today I will be discussing data modeling and how it works and the cardinality behind all of this. First of all, there are just few things I need us to understand. When you look at your Power BI, there are three views that we have and which you should be conservant with. We have the report view, which is where you see your analytics, right? And then we have the table view. For instance, if you go to the table view, this is where you can see different tables of what you have, and according to the way it is, I will come to that, and then we'll have the data view. So what I'm going to do is I'm going to go to the table view to show us the nature of each of the tables and what they are and how they are, so that it can help us to understand what is it that we are doing or we are about to say in terms of cardinality and the data modeling and how you connect your data models. So if you look at the table, there is always a fact table and there is a dimensional table. So what are the confusions around all of these fact table, dimensional table? I'm just going to break it down to you. Fact table is, in other words, the main table. That is where the most of your metrics are. That's why they call them fact table. So if you have a very big table that has, for instance, big columns like this, a big table with columns like different measures, say gender, country, country, maybe CE, or maybe postcode. Then you have another features inside one table as, let's say, salary group, the salary, the age, and all of these. So all of these in one data table can be built into a fact table and a dimensional table. How do you know a dimensional table and how do you know a fact table? It will come to that, but this particular module is specifically for the data cardinality and how we connect it. We'll do another video when we explain some of these other discourse in terms of some of these topics like how the fact table and the dimensional table are even built. So let's just focus on what we had, because I know I have this tendency to always go off and then try to go deep into so many things. So let's just focus. So today this is the fact table, an example of a fact table. So you can see that's where we can see all of them are majorly facts. But the main thing that makes it fact, the actual thing that makes it fact is that is the table that houses other tables. How do you mean by houses other table? That is where we can see secondary keys. A fact table by textbook is a table that has primary and secondary keys. Now, what is a primary key? A primary key is the main key of that particular table. While the secondary key are additional tables that are added to that table by way of what? Keys. You can look at what we have here. So looking at this customer ID, usually the primary key is the first column. That's why we even call it primary, primus, first. So usually the first table is the first column. And why we also call it primary key, it's also it has a unique key for each of the row. It has what? Unique key for each of the row. So there is no repeated key in every primary key. every primary key is unique for that particular table. If you look at customer ID, what it means that if we have about over 1,000, 10,000 rows, that means we have 10,000 customer IDs, unique customer IDs. That's what it means. So it gives you the idea of what is a primary key and what is a secondary key. So because it is primary, this is the salient point. It is unique to each of the rows for that table. That means there is no repeated key for it to be a primary key. It is unique for each of the rows. That is one. Two, it is the first, it's supposed to be, some are not conscious of this, but I like to be professional, in the professional, by way of practice, your primary key is supposed to be your first key because of what? It shows that every row of that column is unique. So that's why it has to be the first key so that you can easily trace things. Let's say I want to know anything about customer ID ending 170. I'll use that to trace it because that is the only place I will see 170. I will not see 170 any other place. I will not see last 3 digits ending 170 any other place apart from here. So that's one. So then secondary keys are dimensional tables that have been connected to that primary key by way of their keys. So these secondary keys are primary keys to a different table. They are primary keys to a different table, but in another table, they become a secondary key. Do you know why? Because there is possibility that they can repeat itself in that table. For instance, you look at geography ID, you can see 11, 11, 11, 11, 11, 11, right? Now, if you look at it, you can see that it's not only 11, there are about what? 3 geography IDs. 3, 11, 12, 13 is the only unique IDs. But because they are secondary, they can repeat each other. So secondary keys are repeatable. They are non-unique, if that is one way you can know it. While primary keys are unique keys, they have unique rows. Why secondary keys are non-unique, that's why they can repeat each other. The same way it goes. Another way to see secondary keys are also, they are primary keys of the dimensional tables. They are primary keys of the dimensional table. So what are the dimensional tables? Dimensional tables are usually the tables that has one category, that has key for one category. So we'll have geography ID, we have gender ID, we have for instance, in this particular data set that we're working with, is it active ID? So which is either yes or no. Does it have credit ID, which has credit ID? So yes or no. That's why you can see is 1 or 0 here, 1 or 0, depending on how this data set was built. So so secondary keys are primary keys to most of dimensional keys, but it's not in all cases, because there are also cases where we'll have 2 fact tables, but we'll come to that. How do you handle it when you have 2 fact tables? I will show you the difference when you have 2 fact tables, and that is what will lead us to cardinality. So that is what one of the things, that's the main thing I need us to understand about primary key and secondary key. Secondary keys are primary keys to dimensional tables. They are primary keys to dimensional table. Let's take a look at one of the dimensional tables that we have. For instance, we have geography. So we look at the geography table. For it to have a key means that it is a key to a table. Either you call it key or you call it ID. These are just different ways. So either we call it key, it can be geography key. Some people call it customer key or customer ID. So either way that you know it, that's what it means. So let's go to geography table. You can see this is that geography table. You see what we call the primary key. Now you see that This is a secondary table. We'll see why we say that secondary keys are primary keys to a dimensional table that is connected to a fact table. So in their own table, they are primary keys. But in another table, they become what? Secondary, because they are repeatable. They are what? Repeatable. They are non-unique to that table. That's why they are what? Secondary keys. But here, in their own table, they are unique. So they are primary in their table, but they are secondary in another table. Just like when you come to my house, you are my guest. I am the house owner. You are my guest, right? That's the way it is. But in your house, you are your house owner. But when you come to my house, you become my guest. So you become kind of sort of secondary, if you should use that analogy. In another person's house, but in your own house, you become primary. So use that analogy to understand it. And they are what you need. You can see that 11 is for France, 12 is for Spain, 13 is for Germany. You see why we also say that they are dimensional or categorical. That's another way to see it. So either you see them as dimensional table or you see them as categorical table. What is categorical? Categorical means each of the key means something. The key is a key to a particular category. So which means for where we have for the cases where we have, let me go back to the main key again. So you see where we see geography ID means 11 means that it is France. So instead of us to have categorical features like France, this, that. So that's another way to model your data into what? Different subtables or dimensional tables. Subtables, dimensional tables, or categorical tables. All of these can mean the same thing. While main table or fact table can also mean the same thing in case if I, use them interchangeably. Now, let me just show us another dimensional table again. For the gender table, if you go to the gender, you see it's saying 0 is female, 1 is male. So you can use, it mustn't be 0 and 1. It can be 0, 1, 1, 1 female, or 0, 1, 1, 1, 2 male. So it can be anything, however you decide to make your key. It can be anything. Like I said, we'll do another module that explain how we even built this dimensional table. But this particular tutorial is basically for primary, secondary key, and the cardinality and data relationship between them. So since we now understand what is a dimensional table, which is dimensional table means they are categorical tables that are brought into unique rows. This is also another way you can see them. So these are other salary table, these are other dimensional table, geography, gender, you see, activity. So 1 means active, 0 means inactive. So it tells you so many things about that in the fact table. So where you see 1, it means that the person is male. Where you see 0, it means that the person is female. So it's also another way of the essence of modeling. It helps the optimization of what you do, because from the onset, our system, our model is built to understand numbers more than text. So it helps in the optimization of your work. That's the essence of data modeling. And in the broad sense of things, in the real practice, for cases, for instance, you're a data analyst that is handling different regions. So your dimensional table can be a table for a particular region, right? So let's say if you're working in the UK, maybe you're working with BT, and you have different offices that you are handling. You are combining different data from different units or offices. So you can maybe have customer ID from different units. Let's say you can have from recruitment or from HR or from sales. these are different. It can be in terms of customer, it can be in terms of employee, but you know what I mean. So these are like different units in which you can use their unique IDs to connect it into one. But we'll come to that. Now, the main thing that we want to discuss today is for us to understand differences. Now, before we go, before we get into that, I'll show you one more important table. I talked about two fact tables. Now, why do we have two fact tables? So let's go to age and tenure. So two fact tables. So like I said, remember what I said about a fact table and what I said about a secondary and what I said about a secondary table, if you can say that. I said that a fact table, or sorry, a fact table can also be a table. There are two fact tables. So how do you know when you have two fact tables? Is when your table is this, when your primary key is the same with the primary key of the other one, or matches it into one. So if you look at this particular table, though it is a secondary table, right? But it has an element of a fact table. What is that element? It has the exact ID. It has exact table ID of primary key. So that's why we can have two factors. Do you know why? Because the age makes it here. We cannot categorize the age. We cannot say, for instance, here we can give one key to a particular category. For if you look at tenor class, so 2 to 3 years is one category, and we can give them 003, right? We can give them that because that's the age group 003. Then again, if you look at another class, the ages are what unique. You see, the ages are what unique to each of the rows. That's what makes it to be unique. And the fact that it has the same key with the primary key, they have the same key. That's also makes it to have two fact table, because the customer ID we have here is the same with the customer ID we have in the other fact table. So in such cases where you have the same keys from two tables, that makes them a fact table. If you see this is a fact table, it has 10,000 rows, right? This is also a dimensional table that has, this is a dimensional table that has 10,000 rows as well. So what that means that we have each of the rows are unique. So if this is a primary key here, if this is a primary key in this table, it also means that it is also a primary key in the fact table. So that makes it to be the same. So with that, where we have cases where you have two fact tables, expect two things. One, the cardinality is 1-to-1. That is the only place when you hear 1-to-1 relationship. What it means is that their roles are the same. That's what it means. Their roles are what? The same. That is 1-to-1. It means each role is matched to each role. I need you to see it. Each role is matched to each role. Also remember what I said about a fact table. I also said that a fact table is also a table that has both primary key and secondary key. So let's also take you back to that age and tenure. If you look at age and tenure, we'll see that this is the primary key for this table. But it has also a secondary key to another table attached to it. It has what? A secondary key to another table attached to it. So here we can see that there is a primary key to this table and there is also a secondary key to this table. So what that makes it makes it also a fact table. So a fact table is a table that has both primary key and secondary key. One way to see it, right? Or a fact table is also a table that has a fact table is also a table that has the metrics in which other tables will be judged with. For instance, in the cases where we have location, if I can remember the tables again, location, geography, gender. These are just simply categories. They don't have any fact about them. So I have location. So what do I need to say about the location? Nothing. But fact table is where you need to now say something about that table. That is what makes it fact. That is where the facts are. The dimensions are their groups, different groups. The facts are now the things that you can use to analyze those tables. So I'm trying to give a different perspective in which you can understand this. So you can see here now, the age group, why this is a fact table to this is because it has a fact for what? For age group. So let's go to the age group. This age group, we can see this is the age group, which is a dimension. A dimension whose primary key, remember what I said about every secondary key is a primary key in their own table. So this is the place where age group ID is a primary key. In its own house, it is a primary key. But because we are talking about age, we are saying the age group are teenagers 18 to 19. But what facts do we have to qualify those that are teenagers, those that are 20s, those that are 30s? Where are the facts? The facts lie where? In this table, which is where we can see the real ages of those customers. So you see, so in this case, we have two fact tables. So in the cases where you have two fact tables, just know that their relationship is what? 1-to-1. That's when you hear 1-to-1 relationship. But when you hear one-to-many relationship, means that the other table is a dimension connected to a fact table, just like in this very case now, in the case between this age and tenor table and age group and age and tenor. So age group is a dimensional table to age and tenor table. It is a dimensional table to this. So if you're only judging these two tables, let's say that this whole of data set is just these two tables. So what that means is this age and tenor is a fact table, while the age group is what? Is a dimensional table. And I've told us dimensional tables are only primary keys to what? To dimensions. What are dimensions? Dimensions are categories. So this is what we call categories, where you have a group of something, Lagos, Enugu, Abuja. These are categories. Or in terms of country, UK, US, Nigeria, India. So is what? Dimension is category. They are categorical variables. That's what we call dimensional table. That's how you know your dimensional table. So you can see teenagers, 20s, they are giving age group keys or IDs. So what that means is wherever we see 1001 teenagers, is telling us that it's a key for all the ages between what? 18 and 19. It is a key for all the tables. It is a key to all the rows where the ages are between what? 18 and 19. The same way goes to here. 1002 is a key that connects to all the rows where the ages are between 20 to 29. And to put it into perspective, we can see here where we are saying the low age and is like a class limit. So this is like a boundary, a class boundary for those of us that do small statistics. But it don't need statistics to understand it. It's just simply telling you the range of that class. This is like a class or age group. So the range of that age group, there is a last number. So only those that are 18 and 19 are considered teenagers in this very data set. That's so teenagers is not just teenagers. Teenagers can also mean 13 to 19. Hope you know. But to put it into perspective, that's why it went further to say between 18 and 19, and even gave us the lower and the upper age for us to get it. So what this means is where we see 30s is only 30s to 39. Let's go back to that age and see if we can connect it. Remember, let me just go back again. Remember, the 30s is 1003, right? So which means all the ages between 30 and 39. If we come here, that is why we call it facts. Fact is where you can now match the keys of those dimensions that you've created, where you match it. So the facts lie here because that is where the age is, right? So you see that all the ages that are 37 lies within that age group of 1003. So 1003 covers all the age group between 30 and 39. Let's see if we can have a difference in, yes, see again, 38 is still within the same word age group of what? 30 and what? 39. So anything 30 and 39 will be covered by what? Age group 1003. So this is a dimensional table connected to a fact table, while this fact table, because of the fact that it has equal rows, equal, not just equal and unique rows to the fact table. That means this can be a sub-fact, because this fact is only for this dimensional table. It is only for, and there is a reason why we did that, why we created this. And I will come to that when we talk about relationships. We'll come to that. We're only dealing with cardinality now. So you can see that this is connected to this by way of what? Primary and secondary key. Now, in our main fact table, which is this, because the customer ID here is equal and unique, they are equal and unique to themselves. That's why they are what? Fact tables. Equal and unique. Equal and unique. So what this means is each of these rows are unique to themselves, one, and they have equal rows with the other fact, with our main fact table. Our main fact table is where we have a lot of metrics. You see what we call it fact. There is a whole lot of metrics where we talked about balance, this, that. So, for instance, these are only just facts. It's telling me H product. It's telling me mean balance. It's telling me we can see salary, estimated salary, credit score. Credit score of who? That is the next question. Credit score of who? We say customer ID. So what other things about this customer ID? How do we know other things about this customer ID? We know them because we have masked them to a different tables connected by keys. And these are the keys, their gender keys, their geography keys. Are they active? Do they have credit? Is there churn? So these are like different separate tables which we have crafted. We don't want them to all be here because they have too much of text. So the system processes number faster than text. That's why this whole thing doesn't mean that we can't just simply have female and male or geography. We can, but it's just a way to optimize your data. it helps in the data optimization, especially when it starts getting bigger and big. Imagine when we start having female, and instead of that female, we're just having 1 and 0, 1 and 0. Check within yourself, what do you think will be faster to the system? It's easier for the system to read 1 and 0, So if we get that, now that leads us back to the main thing that we want to discuss today, which is the fact table is this table called churn modeling. Now, because we have, remember what I called it, a sub-fact table. Why do I call it a sub-fact table? Because inside that table, it has a connection to another table. It has a connect. So this table is not connected directly here. It is connected here, but through here, right? It is connected here, but through here. So from here, I can read what is happening here, but it has to pass through here first before it comes here. Now, that is what. So where you have now these are the salient points. Where you have where you have two fact tables, you can only connect them with one-to-one relationship. One-to-one cardinal relationship. So how do we know? Look at it. The customer ID that is here is the same here. What that means is for each of the rows, for each of the unique rows here is the same with each of the unique rows here. That is the only place you will have what? One-to-one relationship. And that is what one-to-one relationship means. Now, for cases which I showed us, for case in the case of geography, France 11, 12, if I can remember again, 12 was Spain, and then if I can remember the other table. So for the case where we have one-to-many means that here, it is unique here in this table, but it is repeatable here. It is unique here, but it is repeatable here. But one-to-one means there is nothing that is repeatable between the keys. The keys, how do you know how they are connected? When you hover over this line, it shows you how the keys are connected. The customer key here is equal and the same with the customer key here. And since they are all unique to each of the rows, that means it is one-to-one. Each to each, one-to-one. But here, each is to many here. The same way goes to every other dimensional tables we have. Where you have one-to-many means it is one in that table, but repeatable in the fact table. Repeatable means it is not unique. It is not unique to the rows. That's what it means by what I mean by repeatable. Here, the same thing. See, one-to-many. Asteris means many in this case, please. Asteris means many in this case. Here again, one-to-many. Here again, one-to-many. Now, there are two types of relationship. We have what is it called again? Snowflakes and star relationship. Star relationship is where the dimensional tables are connected directly to the fact table. This dimensional table is connected directly to the fact table. This is connected here. This is connected here. So in such case, we'll call it. I'm trying to remember the words. Star table, but let me get that. Let me get that, and let me get that, and I'm trying to remember the word. Yes, star schema. Thank you. So star schema. Why do we call them star schema? So when you hear star schema modeling, it means that each of the dimensional tables are connected directly to the fact table. But Cases where we have bridge table, this is what we can call in this case a bridge table. A bridge table is a case where a dimensional table is first connected to a table that is connected to the fact table. So in such case, look at this. So because of just this one single bridge table, it makes this relationship to be what? Snowflake. Snowflake data modeling is a case where we have a bridge table. A bridge table is a table that connects a dimensional table to the main fact table. So this is that bridge table in this case. It's like a bridge. It will come here first, pass through this bridge before it gets here. It is not connected directly. So assuming we don't have this table, and this table is connected here, we will then call this data modeling to be what? A star schema data model. Star schema is when all the dimensional tables are connected to the fact table. While snowflake is when there is a bridge table. This is what we call bridge table, which is when there is a dimensional table that is connected to a table, which is then connected to the main fact table. So in this instance, you can say that my data model here is a snowflake type of data model. If there is nothing like this, then you can say, oh, it is a star schema data model. So you know the difference between star schema, snowflake data model. And now you now know the difference between cardinalities and how cardinalities work, right? So one-to-many relationship means the primary key here is a secondary key here, right? One-to-one relationship means the primary key here is also a primary key here. One-to-one. Are you seeing how I'm breaking it? One-to-many relationship means the primary key in the dimensional table is a secondary key in the fact table. And what that means is it is what? Non-unique in a fact table. One-to-one means the primary key here is also a primary key here. So what that means is it is what? Unique, therefore one-to-one. So one-to-one, one-to-many. There is also another case of many-to-many, which usually we don't usually often see such cases. They are usually applied in cases like dates or so, where there are many days that can be applied to, but it is a very controversial relationship that one needs to take very, very care of. Now, another thing that we'll look at is the direction. It's very, very important. One direction, the direction is always towards the fact table. That is one. The direction is always what? Towards the fact table. So assuming if I get to any data model, I don't need to ask you where is the fact table. If I look at your data model, no matter how crazy it might look, I can connect the main fact table because of what? The directions. The directions alone is already telling me I don't even need to place it like this, like space them like this for you to know that, oh, the center one is the fact table. All I just need to do is to look at the direction of each of the tables. Where are they heading to? The place where all of them are heading to is what? The fact table. What that also means, the direction, what that also means is whatever that is here can only be read through here, not through here. So anything we are pulling cannot be read here. It is on this table that it will be read. So that information is drawn from these different tables into here. That's also another thing. However, you see why you see why I told you that this is also a fact table, because the information I can read here through here, I can also read it here through here. That's why you see double direction. So what that means is in a one-to-many relationship, we have a one-directional movement. In a one-to-one relationship, we have what? Double what? Direction. What that means is I can read age from this table. Whatever that is in this table, I can also read it from this table. So this, for instance, here, the customer ID here, I can read this from this table. The same way, the customer ID here, I can also read this from this table. That's why it says toOne direction. So from either of the tables, I can read any information I want. That's what it means. So every one-to-one relationship has to be double direction. Double direction. Now, you see, because this is a one-to-many relationship, that's why it's also a single direction to the fact table. So these are like few things you need to understand about cardinality, relationship, and all that. And I hope you do understand this and be cleared of the confusion. If you have any question, I'll put it on the comment section, and I will like that. Before I sign out, let me also show you just how this relationship work. Yes. If I go to edit, let me see if I can show you. Yeah, different. So you see age and group. So you see what you say, many to one. Many to one relationship. Many means that's where the fact is. Once you see many, means that the first table is where the fact is. One is what? The direction. Many is the fact table. One. So when they ask you of the cardinality, so you see the difference. One to one, one to many, many to one. If I change it to one to many, there will be an issue, because this is not. If I say one to many, means that I'm trying to make here to be what? Many. And if I try that, it will give me some kind of error warning. Let's try that. One to many. You see? So you see, the cardinality you selected isn't valid for this relationship, because automatically Power BI matches the relationship. So if you select it manually and you select the wrong one, it will tell you this is a wrong cardinality. Do you know why? Because this is the fact table and this is the dimensional table. So there is no way it can be one to many, because the fact table is the one that has to deal with many, while the dimensional table is one that has to deal with what? One. So the best relationship here is what? Many to one. And your direction is what? Single. Single, because that's just the only thing you need from there. And then you okay it. Let me check another one that has, okay, we did for the case of, so let's go for the case of one to one. This is another case of one to one. So let's see the difference. So this is one to one. And how remember, it tells you the keys, the columns that it is connected with. This is a table and this is the column. This is another table and this is the column. So it tells you the column that you are connecting the tables with. So if you are connecting this table, so you select it, I can select any table and connect to any table. But if I'm selecting this and selecting this, right, I can just say just one to one. Do you know why I'm saying one to one? Because this customer ID is the same here, and they are what? And they are unique to each of the rows. They are what? Unique to each of the rows. So it is one to one. That's the best cardinality, which I have explained over and over again. So automatically, because it's one to one, most one to one has to go with both directions. So these are just, and let me find a case again of many to one, so that you can see how you can edit these things yourself. So here again, this is a fact table. So it first of all tells you the table, tells you the column that you are connecting it with. Then this is another table for geography, and this is the column. So when you are connecting these two, it is telling you that it is what? Many to one. Remember, because this is a fact table. So once the first table is a fact table, please note that it is many to one, right? Many to one. If the second table is a dimensional table, it has to be what? One. And most cases, many to one relationship goes with what? a single direction filter. So please, I hope this will clear us of some of the confusions around cardinality. And if you have any question, please put it on the comment section. Do well to like, comment, share, and subscribe to my channel. Thank you all for listening.